This is section 8.3, trigonometric integrals. So these problems are when you have trig functions, sine and cosine, tangent and secant, etc., that are raised to powers, and what you're going to let your u equal, and sometimes we're going to have to use Pythagorean identities. Okay, so your guidelines are, if your sign is odd and positive, the exponent on the sign rather, so that's the integral of sine to the 2k plus 1. 2k plus 1 is just going to represent an odd number. All right, then it doesn't really matter what your cosine is raised to, because what you're going to do is take one of those sine x's out and save it for your du. And then you're going to have an even power left on your sine, so like sine squared. So I'm right here if you're trying to follow, looking at the formula. So you're going to change that sine squared of x into 1 minus cosine squared using the Pythagorean identity. All right, you're normally not going to have to raise it to a power, but if it was, say, to the 4th originally, then you would have to square that out, foiling it, okay? All right, and so then what you're going to have is you're going to distribute that cosine. Once you FOIL, if you need to, then distribute your cosine, and you will have your sine x dx out to the side, and that's going to be saved for your du, okay? All right, so that is if sine is odd and positive, and this will make more sense when we actually do a problem. All right, now if cosine is odd and positive, so the way you can remember this would be like SOP, sine is odd and positive. If cosine is odd and positive, you're going to take one of your cosines out basically and save it for your du. So we're looking at right here. And then that's going to leave you with an even power on your cosine. Then you're going to use the Pythagorean identity, 1 minus sine squared, substituted in place of that cosine squared, and then you're going to distribute if you need to, and then you have your du out to the side. Using u substitution, you would let u equal sine. All right, and then case number 3 is if both powers of your sine and cosine are even and non-negative, make repeated use of the identity sine squared x equals 1 minus cosine 2x over 2. All right, and that comes from the double angle formulas in trig. It's been manipulated and solved for sine squared and then cosine squared. To convert the integrand to odd powers of the cosine, then proceed as in guideline 2. All right, a lot of this is sometimes trial and error. You just kind of have to figure out what to let your u equal and how to convert it and everything. All right, so in our first example, it looks like sine is odd and positive, which means we're going to take one of those sines out for our du. So we're going to split this up to sine squared x, cosine to the 4th x, and then I'm going to use a different color to signify my du part. So the sign that we took out goes at the end. Sorry, I didn't mean to put du there. I meant to put dx. Okay. And then we're going to substitute in place of sine squared using our Pythagorean identity. So that's 1 minus cosine squared x times cosine to the 4th x, and then sine x dx out to the side. Okay, and so you can distribute if you want, or you could leave it like that. You're going to use u substitution. So if we distribute, we have cosine to the 4th x minus cosine to the 6th x. All right, and so we're going to let u equal cosine of x. du is negative sine x dx. And so as you can see, we have our du. All we're missing is the negative. So we're going to put a negative in the front of our integral symbol. And cosine of x is u, so we're integrating u to the 4th minus u to the 6th du. Okay, simple power rule. So negative 1/5 u to the 5th, and then negative times a negative is a positive, and it would be 1/7 u to the 7th plus c. And then, of course, don't forget to substitute your u back in. So negative 1/5 cosine to the 5th x plus 1/7 cosine to the 7th x plus c. A lot of times they switch these around and put the positive term first. So just, be careful, watch the order. And I'm talking about on like multiple choice answers, okay? All right, let's look at the next one. So this one looks a lot more complicated, but it's still the same pretty much setup. You have an odd power of cosine. So cosine is odd and positive. Okay, and so it's a definite integral as well. I'm just going to drop the integral symbols for now though. So we're going to split the cosine up, cosine squared x. I'm also going to bring that sine x to the 1/2 up, and that's going to become to the negative 1/2. And then we split it up, so we're going to take that other cosine x and put it at the end with our dx. Okay, so looks like we need to now substitute Pythagorean identity in place of cosine squared. 1 minus sine squared x. All right, and so now we can distribute that. So sine x to the negative 1/2 times 1 would just stay the same. And then minus sine squared times sine to the negative 1/2. You add your exponent, so that's going to be minus sine x to the 3/2. I'm just going to write it out side of the parentheses like that. Okay, and then bring down your cosine x dx. So as you can see, you would let u equal sine x. Du is cosine of x dx, which is exactly what we have. So we are going to be integrating u to the negative 1/2 minus u to the 3/2 du. All right, using your power rule, so we add 1, divide by the new exponent. So that's going to be 2u to the 1/2 minus 2/5 u to the 5/2. All right, so we don't have a plus c this time because it's a definite integral. So I'm going to go ahead and put my u back in, which was sine of x. And I'm going to, instead of calling it to the 1/2, call it the square root of sine x. And this would be the square root of sine x to the 5th. That will make it, I think, easier to evaluate. And we're going from, we need to go back and get our lower and upper limits from pi over 6 to pi over 3. All right, so now plugging those in. So 2 times the square root of sine of pi over 3. Well, sine of pi over 3 is going to be the square root of 3 over 2. All right, so that's going to be square root of 3 over 2 to the 1/2. Or, you could put another square root symbol above it or over it, I guess you should say, but we'll just leave it to the 1/2 actually. All right, minus 2/5. These are just really weird numbers. The square root of sine x to the 5th. I should have just left it to the 5/2. So sine of pi over 3 again is square root of 3 over 2. All right, and I'm just going to write that to the 5/2. Okay, minus, so that was the upper limit plugged in. Now the lower limit, sine of 30 is 1/2, so that's the square root of 1/2. And then minus 2/5. So the square root of 1/2 to the 5th, or we'll just put 1/2 to the 2/5. All right, so I actually just plugged all of that into the calculator, and I ended up getting about 0.239. Okay, and you will not have one like that, but it's okay to be exposed to some of these harder problems. All right. Okay, so the integral of sine cubed. So we do have sine, odd, and positive. Okay, so see, even if you don't have a cosine there, you're still going to split this up. So sine squared of x times sine of x dx. All right, but you still want to change your sine squared to 1 minus cosine squared x. This one's just actually a little bit easier since you don't have any cosine x in there. Okay, so you can just let your u equal cosine of x. du is negative sine x dx. So we're just missing a negative. So we're going to put a negative in the front. You're integrating 1 minus u squared du. Okay. All right, so remember that you're integrating with respect to u here, okay? So the integral of a negative 1 du is negative u. And then the negative times the negative is going to be a positive, and the integral of u squared is 1/3 u cubed plus c, and then we need to plug our u back in. So negative cosine x plus 1/3 cosine cubed x plus c. Okay, that one wasn't too bad. All right, so we do have sine, odd, and positive again. So we're going to split up and separate it to sine squared x, cosine squared x, and then that extra sine x goes on the end with dx. All right, hopefully y'all are kind of getting the gist of it by now. So substitute 1 minus cosine squared in place of the sine squared x, and then bring the rest of the problem down. Okay, your u substitution, u would equal cosine x. du would equal negative sine x dx. So we are going to need a negative. You may want to go ahead and distribute this one out. It might be a little easier so you don't get mixed up. So that's going to be, I didn't mean to put u there. That's the next step. So the integral of cosine squared x minus cosine to the 4th x. Here again, you don't have to do that. You can actually do 1 minus u squared and do it that way, like I did that last problem. Okay, so we're going to need a negative integral u squared minus u to the 4th du. Okay, and so that's negative 1/3 u cubed plus 1/5 u to the 5th. So you can kind of see the pattern. It ends up giving you odd powers. All right, go back, plus c, go back and plug in what our u was, which was cosine. So cosine cubed x plus 1/5 cosine to the 5th x plus c. Okay, so I think we've done enough of those. Those have all been pretty similar, except for the one with that square root. That was really weird. All right, I'm actually going to make up a problem. It's not really made up. It's just an extra one from the book that has secant and tangent in it. It's the integral of secant to the 4th x, tangent cubed x dx. All right, so what we're going to do is think about the fact that the derivative of tangent is secant squared, right? So if you think about letting your u equal tan x, then your du would be secant squared x dx, all right? And we actually have secant squared. We actually have secant to the fourth, and so we can split this up into the integral of secant squared x, and then bring the tan cube down. And then we're going to save that other secant squared x to go with our dx, and that's going to be our du. All right, now the problem is we have more than just tan x here. We have secant squared. However, we can convert secant squared x using the Pythagorean identity. So your secant must be even to do this process. Your secant must be even. If it's odd, you have to do a different process. All right, so think about your Pythagorean identity. So tangent squared x plus 1 is equal to secant squared x, right? All right, well, we want to substitute that in. So we're going to have the integral of, so instead of secant squared, we're putting tan squared x plus 1. All right, bring down tan cubed x. And then I have my, what's going to be my du, secant squared x dx, out to the side. Okay, put a little bracket under that. All right, I don't really need to distribute. I'm just going to go ahead and substitute my u's in. So I have u squared plus 1, and then I have u cubed, and then I have du. All right, now I'm going to distribute. So either way, you're going to end up distributing. Just easier once you've changed them into u's, you don't have as much to write out. All right, so the integral of u to the 5th is 1 over 6 u to the 6th. Integral of u cubed, 1 over 4 u to the 4th, plus c. Okay, and then go back and plug in what our u was, and our u was tan x. So 1/6 tan to the 6th x plus 1/4 tan to the 4th x plus c. All right, so that was a little different because it involved the secant and the tangent. Okay. All right, and I'm also going to do one where we have even powers on sine and cosine, so you can see what to do in that situation. So this is the integral of sine squared x times cosine squared x dx. Okay, so remember what it said on the first slide. We're going to use the double angle formulas, and those are going to be on your formula sheet, so you'll be able to have access to those. So 1 plus cosine of 2x all over 2, that's what cosine squared is, and then sine squared x is 1 minus cosine of 2x all over 2. Okay, those come from the double angle formula, which originally is like cosine of 2x equals 1 minus sine squared x, or 1 minus 2 sine squared x, actually. And then you have to like manipulate it and solve for the sine squared, and you do the same thing with the cosine squared, because cosine of 2x actually has 3 double angle formulas if you want to look those up in a trig book, or just Google it. I'm sure you probably don't have a trig book laying around, but you can just look them up if you want to see where those formulas came from. All right, so we're going to substitute both of those expressions in. This is what you would have to do if their powers are both even on sine and cosine. Okay. So then I can FOIL this out. Well, if you notice that what you have here is basically conjugates. You have A minus B times A plus B. So what happens when we FOIL conjugates? We just get A squared minus B squared. Your outer and inner terms cancel. So this is 1 minus cosine squared of 2x all over 4 dx. Okay. All right, so now you have to convert your cosine squared again, because now there is a straightforward integral for cosine squared actually, and I think it is on your formula sheet. So once you get to that point, you can actually use that formula. It's the integral of cosine squared of u. So your u would be 2x. All right, however, I'm going to actually use my cosine squared formula from above. So I would have the integral of 1 minus, so I'm going to have a parentheses, and I'm going to write this actually as 1/2 plus 1/2. I like it better that way anyway. Cosine of, so notice that I already have a 2x for my angle here. All right, but this angle is also 2x. So you're going to have to double your angle. So that's going to make it cosine of 4x. Okay, that's kind of tricky. You have to watch out for that. All right, and then that's all over 4. Let's see, I think what I'm going to do is make that a 1/4 and then make that a 1/4 instead of putting it all over 4, because then I'd have a complex fraction. Okay, so now we can actually integrate it. I'm going to distribute, I believe, first. So let's make that 1/4 minus, so 1/4 times 1/2 is 1/8 minus 1/8 cosine of 4x. Okay, so it's kind of getting a little messy, but we're going to combine those like terms and integrate that with respect to x. So really don't have to do u substitution here unless you just want to do a u sub for your angle, but you can probably figure that part out in your head. So what's 1/4 minus 1/8? Well, that's what? 2/8 minus 1/8, so that's 1/8. Integrated with respect to x would give you 1/8 x. All right, so the integral of cosine is sine, but we're going to divide by a 4 because of u substitution, which I'll show that out to the side. All right, so dx is du over 4. So that would make that 1 over 32, and the integral of cosine we said is sine. Your angle never changes. And then plus c. So we should have 1/8 x minus 1 over 32 sine of 4x plus c is our answer. Okay, so make sure you practice these. These are easy to mess up being multiple choice because your signs, for one thing, are easy to mess up, and also just getting those coefficients right when you integrate. All right, thanks for watching.